Okay, welcome back, everyone. Thank you for joining our second talk of the day here on the sponsor track, track 1. I'm very pleased to be introducing our next speaker from Compass Security, who is Yves Bieri. We practiced that a few times, who will be giving us a talk on the Fido2 security standard. Is that also the right pronunciation?
Fido2, Fido2.
Fido2. We'll together select the right pronunciation by the end of the day. So get your questions ready. We'll have 5 minutes at the end of Yves' presentation. And without further ado, take it away.
Great, thanks for the introduction. Hello everyone, I'm very pleased to be here to give this talk called Suppliers Resist Phishing, Implement Fido2. As mentioned, my name is Yves and I'm a security analyst with Compass. There I help our customers secure their IT infrastructures, mainly websites, but also iOS and cloud infrastructure. And yeah, I've been with the company a little over 2 years now, and I encountered phishing and second factors in my daily line of work, and that's why I'm giving you this presentation. If you have questions, ask right away or in the end if they are a little longer. So I'm sure all of you have seen news articles like those. Phishing is a huge problem, and it's more and more in the news. You read it everywhere. According to different statistics, up to 90% of cyber attacks start with social engineering or phishing attacks. So it is a big problem, and we need to address it somehow. Also, the big players, the big companies have noticed that it is a big problem, and they're looking for solutions. One of them, security awareness trainings. They're great, but they take a lot of time, they cost a lot of money, and usually a couple of weeks, days, hours later, users forget what they were taught and they start clicking on links again. The second thing you can do is use second factors. And this is great, and you should definitely be using second factors. But as we'll be seeing later in this talk, not all second factors are equal, and they're still prone to phishing attacks. And I'll demonstrate that later why that is. So now we have this problem. What we need is a technical solution. Something on a technical level that prevents credential phishing, and that solution is Fido2. And in the next slides, I'm going to explain to you what is Fido2 and how it can help prevent credential phishing and why it's superior to the second factors we currently have. Before I jump into that and into the technical details, let's look at the traditional second factors that we have currently. I'm sure most of you know them. I hope some of you use them as well. You have the ones like SMS, the Google Authenticators, here in Switzerland even Mobile ID. I want to stress once again that most of those second factors do not protect against credential phishing attacks. This usually comes as kind of a shock, even if you're talking to people in IT. So let's look at why that is. We're having this scenario here. So we have the user, the victim on the left, and they have an account with bank.com, the real bank. And somehow through an email or whatever, they got on this phishing bank website. And the assumption is they didn't realize they're on the phishing website. So they log in there, providing their username and password. What the attacker now does, they simply relay that to the real bank website. The bank says, cool, that's correct. Please give me your second factor token. The phishing website relays that back to the victim user. They expect this, so they take out their mobile phone, they look up the 6-digit code and provide that to the attacker as well. Again, in the sixth step, this is forwarded to the bank. The bank has received username, password, and the correct second factor token, so access is granted. So even though this user had a second factor, they still were the victim of this phishing attack. When you show this, the next question we get, well, what if you use some kind of push notification app, like the Microsoft Authenticator in Azure, for example? And unfortunately, it's the same, or even easier for the attacker. So we have the same setup, the same premise. The victim logs in on the phishing website without realizing they're on the phishing website. This is forwarded to the bank. Then, through some backend channel, the push notification or this request is sent to the mobile phone. The user gets a pop-up, obviously clicks approve because they expect it and want to log in. And at that moment, it's game over again, and the attacker has access over the user's account. So when you're thinking of this, you might think, well, this requires really sophisticated hackers. They need some sysadmin to set up the server. They need some UX designer to set up a nice phishing website. They need all of this technical know-how. Maybe this was like that 10 years ago. Today, unfortunately, it's like 5 minutes and an open source tool. So Evil Chinks, I will demonstrate that shortly, is this open source tool that does all of this for you, and it takes literally 5 minutes to set up. So what it does, it just forwards all the requests from the victim to your target website back and forth. It does not break cryptography or TLS. That's important to know. It just does 2 separate connections. And yeah, I'm going to show that with the demo shortly. We're going to phish a user that wants to log into github.com, and I set up the phishing website at cyberstorm.compassdemo.com. Obviously, if this was a real engagement or if I was a malicious attacker, I probably would register one of those domains listed below and not one that doesn't look anything like GitHub. So let's jump into the demo and have a look how this works in real life. Yeah, shown. In the back, can you see it, or should I zoom in a little? Yeah, maybe zoom in a little. So this is the tool I mentioned, Evil Chinks 2. It's for free on GitHub to download. And I already enabled the fishlet here for GitHub. There's a bunch of them that are pre-made that you can just use. If you want a custom one, you can program that. It doesn't take too long and it's not too complicated. And once it's set up, it's pretty simple. Oh, careful with the mouse. I can just get my phishing URL, and I'm going to copy that into the browser, and we just assume that the user got that through some kind of phishing email or something. And I'm having my green browser here. Let's see. And this is the victim browser. So they browse to this website, and as you can see, looks just like the normal GitHub login. You even have the certificate. A Let's Encrypt certificate was created for this on the fly automatically. So what you're going to do is we're going to log in. Well, if that's going to work. And I should get prompted for a second factor. So the victim logged in, everything looks like GitHub, it's GitHub, they can browse GitHub, they shouldn't be suspicious. What's interesting for us as the attacker now, if we switch back to our tool, you can already see certain things have been recorded, like the username and password. This alone is not enough, right? Because there's a second factor. But if we have a closer look at it, we can list the sessions. And this one is the first session, the one we just created. So you not only have like username and password up here, but below here you have this huge blob of data. This is the authorization or the authentication cookie. I hope most of you are familiar with it, but so the server sends this to the browser, so the browser can send this cookie with every other request. Otherwise you will have to provide username and password after every click, and that would not be that nice to use. So as an attacker, I can just copy that and switch over here to my attacker browser, the red one. And let's go to github.com first to show you that I'm not logged in, not fooling you here. Connection is working, even if it's showing that. So as you see, I'm not logged in currently, but what I can do with one of those plugins that exist a lot, I can just import this cookie. Simple as that. And if I refresh now, hopefully, ta-da, exactly. Yeah, and as the attacker, we successfully took over the account of that victim user, even though they used the second factor. So it can be that easy. Let me quickly disable the phishing website before anyone tries any funny things with it and leaks their credentials. Fishlets, hide. Cool. Yeah, I hope I could show you why phishing is a problem and why even normal 2FAs are not enough. So, we've seen awareness campaigns good, but not effective after a while. Second factors, we just bypassed it. So we really need some phishing resistant protocol that protects us from credential phishing. So now I'm going to talk about Fido2. If you Google for Fido2, you're going to find all those abbreviations. U2F, UIF, CTAB, and so on. Looks really intimidating in the beginning. It's not that bad. I'm going to go through them, and I hope at the end of the talk you'll understand what they mean. So FIDO stands for Fast Identity Online, and it's a standard that's provided by the FIDO Alliance that was founded in 2012 by PayPal, Lenovo, and Google, and a few others. Now there's a lot more companies that are part of the alliance. And what they did initially, they kind of two things they wanted to combine. One was some passwordless experience that came more from the PayPal side, that you can approve transactions without a password, for example with biometrics. That is UAF, the Universal Authentication Framework. And on the other hand, you had Google. They were looking for a phishing-resistant second factor, and they had the U2F, the Universal Second Factor, that they used for their employees. And they kind of came together and merged those. And what happened was Fido2, which replaces those two standards. So you already can forget those two abbreviations because they're not relevant anymore. Let's look at the building blocks of Fido2. So you have in the middle the client. That could be your typical web browser. It was the Google Chrome before. On the right, you have your relying party. That was GitHub in the example we did before. And the authenticator, that's your second factor authenticator. Let's look at how those could look like. There's many of them, probably the most well known up in the middle, the YubiKeys from Yubico, also Windows Hello, and there's a few other keys. I'm sure if you ask the security people here, most of them will have a key like this somewhere. Then the clients, pretty much every big browser nowadays supports Fido2. So Google Chrome, Firefox, all of them. You can use it on Windows, on Android, and I think since iOS 14 also Apple is pushing for Fido2. And the relying parties, the servers, pretty much every big website supports it by now. Microsoft, Google, Amazon, and many more. So it's pretty widely adapted. Let's look at some examples how this could look like. In a typical scenario, you could have the user on their laptop using Google Chrome to browse to GitHub, and then they would use the authenticator through USB to approve their second factor. They could also be using their mobile phone, exact same scenario, but this time they could use NFC with the phone, because for example this phone here has NFC, but it doesn't have a big USB port, so it would be kind of difficult. Or finally, you can also have it integrated in your laptop directly. If you have a Windows laptop with a TPM, you could be using Windows Hello and the browser on the same device. So Fido2 pretty much has those two standards, WebAuthn and CTAP, Web Authentication and the client to authenticate the protocol. And let's look how they come into play with our different building blocks. So the client, the browser, somehow has to communicate with GitHub, so the user logs in, and then somehow, this is done over HTTP, and then GitHub has to prompt for the second factor being done over Fido2. So this is done through web authentication, this API. So far so good, but then the browser has somehow to communicate with the key, right? What's being done there is the CTAP protocol is being used so that the browser and the stick can communicate with each other. For CTAP2, I already mentioned it before, you can be using it through USB, through NFC, or also through Bluetooth Low Energy. The good thing for most people in here, you probably will never have to deal with it, unless you want to create your own second factor stick, or you implement your own browser. If you're doing one of those, yeah, you have to dig into the specifications, and they're pretty long and difficult to read, speaking from experience. Otherwise, you don't have to care too much about CTAP. On the other hand, web authentication, the JavaScript API that's used between the browser and the website, if you're a developer, you have to look into this so that your website can provide Fido2. Since a bit more than 2 years, this is now also an official standard in W3C, in the web standard. And yeah, as we've seen, most browsers support it by now. Now that we have like the theory block out of the way, let's look at how the protocol actually works in practice. So it's a challenge response protocol using public key cryptography. So you have a public and a secret key. And again, we have this set up with the relying party, the client, and the authenticator. And the user, they go to this website and they register an account. They create this, and then they start to enroll their second factor. For this, on the key, you create a public and a secret key. You provide the public key to the website that you're registering with, and you keep the private key, the secret key, on the authenticator. For every website, you create a new key pair, so you can have multiple stored on there. You could have one for GitHub, one for Google, one for Microsoft, and so on. Now, after this has been registered, the user can log in using Fido2. So the first step is the same. They provide username, password usually, right? What happens now is that the Fido2 protocol starts. So the server, they send a challenge, some random number, and their origin. The origin you can think of as what's written in the URL bar. So it could be github.com. Side note for the super technical people, it's not really the origin, but it's close enough for this talk. So after this has been sent to the browser forwards this to your second factor device, for example, a YubiKey. The key looks up the secret key for this origin where you have been registered before, and creates a signal or signs the challenge with that secret key. This signed challenge is then forwarded to the client and finally sent back to the relying party, to the server. The server looks up the public key for that user, tries to verify the signature, and if that succeeds, the user is successfully logged in using Fido2. Nice, right? So, why does this protect from phishing? We haven't answered that yet. So, let's look at this. There is a few different parts where it helps, but probably the most important one is the first one here. So, when the challenge and especially the origin is sent, we were in our phishing example before, we were on GitHub initially, or that's what we wanted to browse, that's where we wanted to log in. that would be the origin that's being sent, but actually in the browser, there is cyberstorm.compassdemo.com. And part of the protocol, the browser checks whether those match, what's actually in the URL bar and what you receive from the server. And they don't match here. So the browser will terminate the protocol here, throw a security error, and the user will realize that something is fishy. Now, I'm sure some of you already saw what could happen. If I'm in this position as before, where I'm forwarding back and forth all the traffic, I could just simply switch the origin and say, okay, it was GitHub, but what happens if I just change it to cyberstorm.compassdemo.com? Then we will actually pass this first check, because then this will actually match what's in the URL bar. What's then happening is, when we prompt the key to look up the secret key for cyberstorm.compassdemo, the key realizes there is no key pair created for this website. So they obviously cannot sign the challenge. So it will fail at this second step. Also, a security error will be thrown and the user won't be logged in. There's a third, more abstruse scenario, but I think we should talk about it nevertheless. Let's assume Google, for whatever reason, wants to impersonate GitHub, and they create a phishing website, and they send that out. And the first step to bypass this, again, they change the origin for Google, and to match that with the phishing website. And we'll pass that. In the second part, there could be a private key, a secret key that is stored for Google. So the key would actually retrieve that secret key and sign the challenge that it received. So far, so good. This will be sent all the way back to the server. Now GitHub here as the server will look up the public key of that user. And with this public key from GitHub, it obviously cannot verify the signature that has been created with the secret key from Google. So the server here, in this case, will realize that something went wrong and will abort the protocol, and the user won't be logged in. So you have like all those components that are working together. So you have the browser that's responsible for some things, you have the stick that is responsible for other parts, and also the server that is responsible for verifying or making sure that phishing is no longer possible. Yeah, with this I just wanted to leave you with a few bullet points with a short summary of what you hopefully learned in this talk. So we saw phishing as a problem, but the traditional methods we have don't provide a good enough solution. Often they're inconvenient or not resistant to phishing at all. And what I can show you is, or hope to explain to you, is that Fido2 should be used, and it's a great protocol that prevents credential phishing. It's super simple to use, right? You don't have to have 7 apps and try to find where's your website. Just plug in the stick and press the button, and it's done. And nowadays, it has really strong platform support. All the major browsers support it. All the major websites support it. So I really encourage you to use Fido2 and to implement Fido2. Thank you very much.
Thank you, Yves. I'm so impressed at how you did that demo with absolutely no mistakes in it. Normally, there's always some technical disaster that happens. Any questions? Great presentation there. Yep, there's someone coming around with the mic. If you want to say your name and where you're from.
My name is Fabian. I'm from Kolp. What if you lose the key?
Yes, good question. So what is encouraged is that you not only have the key as a second factor. So there's a couple of possibilities. You can buy 2 keys and register 2 keys, keep one safe somewhere. That's one possibility. Maybe not so nice because you have to buy 2 keys. The easier one is you use the key for everything you normally do, and you have like Google Authenticator or SMS or something as a backup, but you don't use that. So you can choose as the user which kind of second factor method you want to use. So if you, in your everyday life, all the time use this, you're protected from those phishing attacks. And if you lose it, for that one time, you just need to make damn sure that you're on the right website. Then you can log in with your other second factor and register a new key. So, yeah, it's obviously bad if you lose it, but it's there is ways around it.
Brilliant. I think we have another question right here.
Yes, I'm from the Kantonspolizei Zürich. I have a question to Evil Jinx. Is it only the landing page which is copied? Because afterwards, if I browse to my repo, for instance, then I notice that it's probably a fake site, right?
No, it should be forwarding all. It's just rewriting everything where github.com is in it. It just rewrites it to the phishing website.
Okay,
So it just replaces everything. So you
Okay.
can browse it normally and it just looks like the real deal.
Okay.
That's what makes it so dangerous.
Okay, thank you.
Yeah.
Thanks. And another question over here. Loving the engagement. You have incited something.
Hi, I'm Marco from Unicodata. What if we have a fake DNS in the promised host or a fake host entry?
On your client, you have
Yeah.
a DNS that points to, instead
To-
of GitHub, it points to your phishing website.
Yeah.
Yeah, probably the certificate should.
Certificate is from the Evil Jinx. It's okay. Okay. Yeah. Makes sense.
Yeah, you cannot. Yeah, you cannot get the certificate because you cannot prove it. You can do it here because it's another domain where you can get your own certificate from Let's Encrypt. Thanks.
We have time for one more question or comment. Anyone have anything else to add in that great presentation? Why don't we see more major organizations or institutions picking up this standard?
It's a good question. I mean, internationally, we see a lot of the big companies moving towards it. In Switzerland, I don't know of any bigger companies like banks and so on that are using it. I mean, if you use something like the Authenticator or SMS, then the users already have their phone and they can use it. And you would have to provide each user with some kind of hardware stick for them to use it. Obviously, against phishing, it would be great, and I would encourage the big players to use it, but it might take some more time. If now Microsoft and Google are starting it, hopefully it will roll over also to Switzerland.
What's the cost of this in comparison to?
So there's the cheapest model. I think they go for around 30 francs, 35 francs. And then the more expensive ones with more features go to like 60-ish francs. But you can have the protection with the cheap one for like 30 francs. So a week's worth of coffee in Zurich.
Thank you very much. Another big round of applause for Yves. Thank you.
Thank you.